afternoon, and welcome to the first. I just like to say that first. Anyway, for our tips and tricks, we're going to talk about something related to synchronization and concurrency. So the problem is that if you have work, if we have work to be done that access or change resources, we can encounter situations that cause deadlock, starvation, or crashes in our applications. So we're all familiar with that. We have resources, maybe I/O or values. So one solution that can help us is something called compare and swap. It's lock-free, that means it's fast. It uses atomic operations as opposed to heavy synchronization like mutexes and locking. Okay, so what I know related to compare and swap is only on JRuby. So it uses atomic integer and all the atomic XXX classes like Boolean, atomic Boolean, arrays, or longs. You can also have atomic references or arrays. It's good because it has an easy API, very understandable for something very useful. So the demo, for example, we have something like this, the worker simple. So let's go through the code. So we have a resource, which is this one. And then what we want to do is add to that resource. So basically we want 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But we're going to create workers to do that for us. So we create the workers here. For each worker, they have a condition where they can do the work. So for each worker, it expects this before it can do the work. And then we run the worker. So what the worker does is, if the last value of the resource is what we expect, then we do our job, which is to append the next increased value. Okay, so each worker, if it's this value, I just increase it by 1. So that way we can get the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's run that. So as you can see, it's running, but it's not what we expect. So the thread, we output that the thread sees the index in this condition, 0, 1, 1, 1. And then it increments, and then the next thread also outputs what it sees. So that's not what we expect, because obviously one thread saw that the value was still 0, and then increased the value and appended that value. But actually, the last value was already 1, so there was some interleaving of operations. Okay, what we can do is we can synchronize this is, I don't know how to do it in non-JRuby, but maybe you can use a manual locking or some mutex. But what we do is we have a lock, which is this one, and then we synchronize on that lock. And then everything that's sensitive, we include in that block. So this entire thing is sensitive. So we include that there. So okay, let's try that. Workers what? Sync. Okay. Okay.
Good sound effects, guys.
Okay. Whew. So we see that the threads are seeing consistent values. So we're building the resource correctly. So at the end, it's good, all good. But what was the problem? Very slow.
So all the threads stop.
Yeah. This means that only one thread can execute in that block. So the other threads have to wait. Okay. So what do? We use compare and swap. So what does it do? What's the difference? So we have our atomic integer here. And instead of doing synchronization, we do compare and swap. So if we compare, we expect this value, compare first, and then set the value. Okay, then we do the work, and then we set it to the correct value. So how does that work? So yeah, you can see that the resource is also consistent, but it's much faster. Okay, so that's it. So lock-free, synchronization, atomic operations, very good alternative to synchronization, which is more heavyweight. Thank you.